Good morning, everyone. Thank you so much for the opportunity to speak with you. I promise not to speak Chinese because that would be a very short presentation. But I will tell you that I have been coming to Taiwan for more than 10 years. So it's really an honor for me to come back here. People say things like that to be polite, and I don't say things just to be polite. I say thank you to be polite, but I really mean that it's always an opportunity for me to come here to visit friends, to build guanxi, to have some time to experience the culture and to see all the change that's going on here. So it's really a wonderful opportunity. I'm so happy to be able to do this. The other thing I will say is that I am from New Jersey, and people in New Jersey have a tendency to speak very fast, and they have a tendency to sometimes not speak very clearly. So if you think that I am speaking too fast or not very clearly, please don't be polite and nod. Just put your hand up or something, and I will try to pay attention to that. Promise, okay? Before we start, because I have so many very smart people here, and to your comment about the PhD, I am doing some research all over the world, and I would appreciate if you would help me with my research. You don't have to, because you are human subjects and you are free to refuse, but I hope that you will help me. It's a very simple experiment, and I will explain it when we're done. So I'm going to put my hand up like this, and when I put my hand up, I would like everyone to please clap one single time. Just one clap, okay? Ready? Okay, that was the training round. Okay? Now, there's always an overachiever, and there's, okay. Now I'm going to do it again, and this time is the real experiment. Ready? Okay. Now the last time, I'm going to do this one more time, and this time, instead of clapping one time, please clap 3 times. Not one clap, but 3 claps. Does everyone understand? Ready? What did you notice? Noise, sorry? Synchronized. Synchronized. How did we know how fast to clap? How did we know what speed? I didn't say, I want you to clap exactly 3 times. I didn't say, ready, set, go. Somehow, all of these human brains with all of these neuromorphic computers in between our ears communicated at some level with information that we don't completely understand, and shared at some quantum level, probably not really quantum, how to clap. Now, there's social norm that goes into that. I can tell you that in some parts of the world, if you do this in Germany, it's clap, clap, clap. If you do it in Japan, it's very polite claps. Different parts of the world, some you do it in the U.S., people try to outclap each other. But the speed is what's interesting. How do we know how to be in sync? Now, the other thing that's interesting is, and this is all going to relate back to this presentation, I promise. The other thing that's interesting is if you watch a video of what just happened, it wasn't nearly as synchronized as you remember it. Because our brains are constantly organizing the world around us to help us understand. And so we organize things and we remember them in ways that are not exactly the way they really happened. So I would like to suggest that that's a very good metaphor for the fact that we don't totally understand the computers inside our head, and yet we use them every day. And there are things that are going on that are more complex than we realize until we pay attention to them. And that's a good theme for what I'm talking about here. So I'm going to talk about three parts to this conversation. If at any time you want me to go deeper, I realize there are people in this audience that are experts in AI and neuromorphic methods and deep learning and deep belief and computer malfeasance and cybercrime, and I promise I will go deep into any one of those things if you want me to. I'm going to start here, but we don't have to end here. So please stop me if you want me to, and then we'll have some time for questions later as well. And later on when I trip on this cord, because I keep walking around, someone please come and save me. So the first thing I would like to point out, I just rattled off a whole bunch of technology. And we do this all the time. We talk about innovation, and the way we talk about innovation now and the way we talked about it 5 years ago is so different that some of the things that we're talking about now were science fiction only a few years ago. Only a few years ago. If you told me, and I'm pretty knowledgeable about this stuff, if you told me that in just a few short years we would have autonomous cars that actually could drive in traffic with crazy people, I would say, I don't think we're going to get there that fast. I think we'll have autonomous cars, but they'll have to have a perfect white line on the road, and they'll have to have, no. We're dealing with confusion. We're dealing with things in ways that I think if we tell the truth, no matter what your field of study is, if we tell the truth, the rate at which this is advancing is much faster than we thought. I'm very interested in quantum computing. And quantum computing, anybody here an expert in quantum computing? Good, then I can talk about it. You know, quantum computing is a fascinating thing. If you're not paying attention to it, really you should read something about it and at least get some basic idea of what it's all about. The fundamental idea behind any digital device, whether it be this or your computer or your phone, is that everything comes down to a bit, a 0 or a 1. In quantum computing, the fundamental unit, the qubit, is anything between 0 and 1, including complex numbers. So like these little buckets of infinity. And the type of algorithms that you can write when the fundamental unit can have superposition that is essentially infinite are totally different. So complexity theory changes. Things that are NP complete, NP hard, become trivial. Certain things that involve decay just happen automatically in the hardware. You don't even have to write a program. So that completely changes the way we think. Some theorists said that when we get to a 50-qubit quantum computer, you will reach this concept of quantum supremacy, where that computer is more performant than any high-performance computer in the world. I just came from visiting a 50-qubit quantum computer in a laboratory. It's not totally stable, and there are some people that argue about whether that number means anything, and don't really care. I looked at it, I saw it, I touched it. I didn't touch it, it was behind the glass. But it's actually, the temperature at the bottom of the stack where the qubit is colder than outer space. Because they have to keep it very stable in order to make things work. Quantum computers are weird. They're really weird. There's some really strange things that go on there. And some people think that they might be able to break strong encryption. And there's this thing called quantum entanglement, where the sender and the receiver have the message at the same time, so you don't even need encryption. So if somebody isn't thinking about quantum computers and quantum hacking and quantum malfeasance, I use that word a lot, bad behavior, they sure better, because it's coming. So this science fiction thing, you know, we should probably pay attention to what we consider science fiction, and we should probably keep reading to make sure that it hasn't become science fact, because it's happening every day. I try to stay on top of this. I try to understand where the edges of certain technology are. My strong interests are in connected space, understanding how things relate to each other and how information influences other information, how behaviors influence behaviors. The science here will change all of that. The future is already here. It's just not very evenly distributed. I love this quote. People use it a lot. And I would add, why would we assume it's all for the good? So, the people who are doing amazing things are not doing them in China or in the US or in Taiwan or in Germany or in, pick a place, Russia. They're doing them in cyberspace. They're doing them in a way that we don't have the right words to describe right now. The ability to collaborate, to share open source code, to steal things, to observe things and use the information from that observing, the metadata, the ability to process unstructured data is growing at a rate that is beyond terrifying. A few facts. We used to measure the rate at which the amount of data on Earth doubled. Can't really measure that anymore. You can find things on the internet that will tell you how much data there is on Earth. They're actually not correct. If you read all the fine print, They're talking about how much data there is on the internet, or how much data is being created in the storage industry, or how much data we don't know exactly how much data there is on the dark web, or how much data there is in the Internet of Things. My fitness monitor is collecting data right now as I'm walking back and forth. They're not counting that, right? Every one of you probably has at least one phone, right? And you're here in a meeting, so somebody sends you an email and they get a response back saying, I'm not available right now. Well, your agent, your electronic agent, is sending and receiving information on your behalf. So that's a little bit alarming. The rate of increase is so great now that it's arguably unmeasurable. So what does that mean? It means that this is the age right now where there's no guarantee that things get better. We may drown in our own data, or we will find a better way to deal with this. Just turning the crank harder and working harder is not going to get us there, I promise you. Has anyone here ever heard of a Red Queen problem? This is another good thing to look up. Fascinating, Red Queen problems. I wrote a blog on it if you're interested. The idea behind the Red Queen problem comes from the story of Alice in Wonderland. I don't know if you know the story, but a little girl, she goes to this magical place, and all kinds of strange things happen, and at some point Alice winds up at a tea party with the Mad Hatter and the Red Queen. And Alice says to the Red Queen, this is such a bizarre place, I don't understand. I'm running and running and running, and I don't seem to be getting anywhere. And the Red Queen says to Alice, that's exactly the kind of place this is. You have to run as fast as you can just to stay where you are. So a Red Queen problem in computer science is something where there's no guarantee that putting more effort into it will make more progress. Red Queen problems require orthogonal thinking. You have to do something dramatically different in order to solve a Red Queen problem. All of this data is creating Red Queen problems every day. And if we tell the truth, the response of leadership in most organizations is to tell people to work harder, or to try to hire more people or smarter people. There is no guarantee that doing that will make any progress. So we have to think differently. And that gets me to part one. So that was the introduction, right? I want to talk a little bit about the fact that not only is there way too much data, but it's not really about the data. It's about the questions that we ask. So I started by asking you all to clap, and thank you for participating in my experiment. By the way, the benefit back to you was knowing about the experiment. There always has to be some benefit to the subject. Right? I don't want to get in trouble with the IRB people. So asking the right question is so critical. I'll give you an example. You know, Dun & Bradstreet, we have the world's largest commercial database of its type. It's updated millions of times a day from hundreds of countries. We have 6 integrated global supply chains. This data is collected in different languages and different writing systems. There's different laws in different parts of the world about what data may move, what data may not move, privacy. We manage all of that to deliver data to our customers and services to our customers about total risk and total opportunity, sales, marketing, credit decisions. That's what we do. So one day I'm sitting at my desk and I get an urgent email. Emergency, 2 hours response, RFP, blah, blah, blah. I open the email, and the story is, it's an insurance company, it's a good customer. We're responding to a request for a proposal. We have 2 hours. Now, I know we probably had this for 2 weeks, but by the time it got to me, they had 2 hours. And there are 7 mandatory questions. We've answered 6 of them. We need you, science guy, to answer the 7th one. And the question was, how many businesses will there be in China 4 years from now? I don't know. Nobody knows. So I wrote back to the guy and I said, I got your message. I understand who the customer is, but it's important to understand what they're going to do with the answer, because I have to make some estimates about organic growth and organic decay and our willingness to invest in geopolitical situations and growth and linkage and lots of different things. And if I understand what you're going to do with the answer, I'll make those estimates more or less sensitive to what I think the customer will care about. And he wrote back and he said, now we have 90 minutes. So I called him up and he said, look, I really don't know. I have no idea why they're asking this question. It has nothing to do with the proposal, but we can't submit it without the answer. I wanted to just make up the answer by going to the last 4 years and drawing a straight. I said, please don't do that. That's not going to work. Promise me I can talk to this guy next week and I'll give you an estimate. So he said, okay. So I did all the math, gave him a beautiful estimate, and the next week I'm talking to the customer and I said, I'm the guy that told you how many businesses there will be in China in 4 years. You know that I don't know that, right? And he said, of course I know you don't know that. And I said, well, why did you make me answer the question? And he said, well, my boss is making me answer the question. So I said, okay. So eventually, after a number of questions, what we got to was that they were doing sales and operations planning for ocean-going freight insurance. So I said to him, so when you ask about growth of businesses in China, you don't care about hotels and restaurants and banks. You care about companies that make things that get shipped by ocean-going freight. And he said, well, yes, of course. And I said, and furthermore, since this is sales and operations planning, you want to have a different penetration rate for your existing customers and their growth and your non-customers and their growth, because it's more difficult, right? So what you really need is a 4-factor analysis in and out of industry, in and out of your customers' global family trees, projected over 4 years in the geography of China, probably focusing on the eastern seaboard of China because it's ocean-going freight. And he said, yes, that's what I asked you for. And of course, it was not what he asked me for. And I gave it to him. I did the new analysis, and then he invited me to his Christmas party. So that's all about asking the right question. It's not about data. There's tons of data. Anybody can push a button and draw a regression line and say, here's the answer. Somebody in 8th grade can do that. Probably now they can do it in 4th grade. It's not difficult to do regression. It's difficult to understand when regression is the right thing to do. And that's a totally different conversation that has nothing to do with technology or data. And I submit to you that as we are getting better and better tools, we're getting more and more people that know less and less about technology. It's really scary. So, when I was in school, this is what information collection looked like, right? A bunch of people sitting on a train, reading newspapers, listening to some sort of radio or something, and they're listening to things that are not, people that are not there, about things that happened in the past. And they stored the information on hard drives and computers. I understand that. Today, information is stored in the cloud. There's all kinds of cyber threats, and the creation of information kind of is a little weird. I don't know what's going on here anymore. I don't know if this guy is communicating with this guy about her. I don't know if she's at work doing some kind of, meeting, virtual meeting. I don't know if there's augmented reality going on here. I have no idea what's going on. Neither do they. So if we tell the truth today, understanding the creation and curation of information is a little bit of art. It's not all science anymore. It's not easy to understand where things are going. And now regulators are trying to write laws to control all of this, which they should, right? But if they over-control it, then we kill the economy. And if they under-control it, then these bad guys win. So this is a very, very, very complex situation that we're in. I made a word cloud of my thoughts. When I think about data today, this is roughly what I think. So this is my word cloud of what I think is sort of at the forefront in data. You should probably make your own word cloud because it's a very useful exercise. If you sit down and you just write, free think, when I think about the concept of data, what do I think about? Write down all the words that come to your mind and then put a number next to them in terms of how important you think they are. And then make a word cloud and say, is that really how I feel? And then stick it up on the wall and cover it and look at it in 6 months and see if you still feel that way. So what's missing on here, because I made this a while ago, was the dark web and cyberspace. But other than that, permissible use was very important in my mind at that time. Obviously big data, relationships among entities, privacy, all the V's of big data, velocity, veracity, variety, volume. What does the data mean? Unstructured data. About 85% of all data that we're creating as a human race right now is unstructured. And we're not very good at dealing with unstructured data, right? Which means that we're not dealing with about 85% of the data that we're creating other than storing it. That's a little scary. So what are some of the behaviors that I see? You know, they teach us all in the scientific method that the first thing you should do is observe your environment. So that's what I'm trying to do here, right? I see this unstructured data. I see language and use of language constantly evolving. I see data making data. I see the rate of increase being unmeasurable. This is how I see the environment right now that we call data. And then I look at our customers and their questions and the way our customers talk to us. Are those questions getting more and more difficult? Or are we having the same conversations year over year? That's another interesting way of measuring progress. So the first one is inside out. This one is outside in. It's always good to have different perspectives when you're doing qualitative research, right? And some of you, I don't know your backgrounds, they sometimes call this emic and etic perspectives, right? So I'm trying to do that. And then I look at some of the really smart people who are also thinking about these concepts of digital usage and how we're using our data. Here's two different models, right? I know this guy very well. He's a really good guy. You should read up on some of what he writes. I don't know this guy. This model is pretty simple. It just basically says, look, people will always be better at things that involve creativity and curiosity and sympathy. We're pretty sure that even with AI, people will always be a little better here. Over here, things that are routine, things that are standardized, things that require compliance, maybe machines will eventually be best at most of that. And somewhere in between, there's this play between the knowledge that we need and how we learn it and what we do to manage it. And this is how this person sees the digital world. So basically, his message is, we're not going to lose. Computers are not going to take over the world, but they're going to do a lot of what we do today, and we're going to do something different. That's pretty much what he's saying. This guy over here has tried to take a number of concepts and overlay them in what I think is a particularly brilliant way. So the first thing he has is certain future scenarios. These are things that are driving change. And this might be a good sort of conversation about, you know, when you start to think about the priorities, the digital priorities here in Taiwan, instead of thinking about them from the perspective of technology, thinking about them from the perspective of what's drawing that technology to be needed. So we have things like the automation of everything. We have cyber wars. We have energy usage. We have things like money 2.0, cryptocurrency, things like that. Logistics, empowering economies, serving marginalized others. Those are sort of the drivers, the yellow ones. And then the blue ones over here are the sort of the things we understand as the disruptive influencers of technology today. So mobile, social, cloud, internet, big data, we get that. Everybody knows all about that, right? And then we have these things here, which are sort of in between. These are technologies that are driving these concepts, these future scenarios, to become true. So as an example, we have robotics, we have blockchain, we have 3D printing, we have renewable energy. Now, I'm not sure I would put all of these things on the chart, and you can make your own chart like this with your own drivers for your own economy here. But this way of thinking about sort of the from, the transitional, and what the future scenarios are is a brilliant way of thinking about this. All of this stuff in the middle is things that we see. So if we're going to be scientific about it, we have to say, well, urbanization. We know that urbanization is occurring. This is sort of an axiom. We can measure the population of city centers, and we can see that city centers are becoming more populated. Therefore, urbanization is occurring. This is not something debatable. This is positivistic knowledge, right? How do we take that urbanization and understand it in the concept of the Internet of Things? Well, if we're going to have smart cities, and if the heating and air conditioning systems are going to be somehow coordinated with the traffic systems so that we can do a better job of guessing when people are coming home or something like that. I just made that one up. But if things are going to sort of talk to each other and discover each other, and if urbanization is in fact a fact, then we can argue that the impact of working on technologies like that will be greater than it is today. So there's an economic value that exceeds the ROI, the return on investment, that we might calculate today. The future investment might actually return more than the current investment, and that might be an argument that helps us move to technologies like that. So this is a really nice way of thinking about some of the environment around us and deciding how we react to it. I love it. And what I love about this thinking is not once have we really needed to talk about the actual pieces, the tools. I haven't mentioned Python, I haven't mentioned R, there's no such thing as PAR. I haven't mentioned Hadoop and Spark, and who cares? I mean, those are all tools. We should be talking about the house, not the lumber. And we spend a lot of time talking about the lumber. Another way to think about this is the roles of the people in the organization. So it used to be that we needed people that were data curators, analysts, modelers, statisticians, methodologists. Today, if you're going to do data science, you also need to understand governance and problem formulation, and you have to be a bit of a detective and maybe a visionary and a storyteller and a diplomat. You have to do all these things, but you don't get to stop doing all of these things. So what do we teach our children? What do we teach our students in school that's going to be relevant 3 years from now? My argument is more of this and the same amount of that, which means that they've got to work harder. I first took calculus when I was in my late teens. I'm pretty sure that calculus was introduced a little earlier now. I first got exposed to computers when I was in high school. Now, children are born, in the maternity ward. There's some device that they hand them. I'm joking with it. It's pretty bad, right? So, the demands on our learning are increasing. Okay, so the first part was just observing the environment. The second part is, what are we doing about it? What are some of the forces that are driving change today? And is what we see consistent with what we hope it to be? And by the way, I'll give you a hint. The answer is no. One of the things that I see is our customers have the same problems that we do. So as we try to serve our customers to do things more intelligently, more analytically, we don't want to be seen as a big database. We want to be seen as walking that walk with you and helping you solve a problem, right? Well, at the same time, that customer has a new problem. Many of our customers are high-tech manufacturers and financial services companies. So a financial services company today is worrying about what a bank will look like in 5 years with blockchain and fintech and all of this change. And they weren't worrying about that 5 years ago. They were worrying about issuing credit to small and medium enterprise. Today, they still have to issue credit to small and medium enterprise, but now they have to worry about blockchain and cryptocurrency. So the same thing is happening to them, and they're being destabilized in the same way as we're being destabilized. For those of you that are involved in principal research right now, if you're doing postdoc research, you probably have people on your team, in your lab, in your group, working with you, who did all of their research electronically. I didn't do all of my research electronically. I had to order books and wait for them to come in the mail. Now, some of it was done electronically, a lot of it was, but some of it wasn't. I had to go to libraries. A library today is something digital, right? So we have to be mindful of the fact that the environment that we're disrupting is itself being disrupted. And that is a very powerful observation. We also should realize that there are forces that are sort of in opposite directions. We have this yin-yang going on. So these are all the things I've been talking about that create opportunity. The Internet of Things, artificial intelligence, blockchain, fintech, virtual, are all great opportunities. Over here we have cybersecurity, malware, data sovereignty, data protection, privacy. Well, these things make it a little harder to do these things. And they're both happening at the same time. Let's take the Internet of Things. I think that's a big deal here, right? The Internet of Things is not an Internet of Things today. It's an Internet of Things connected to the Internet. All of those things go back to an application, and that application processes the information. Those autonomous cars that I was talking about, they're not connected to the Internet all the time. They have AI built into them. Their AI has goal functions. Those goal functions are using data, some of which will come from the Internet of Things. When the environment changes, the AI in the car has to be able to modify its goal, just like your human brain does. How's all that going to happen if everything's not connected to everything? And how are we going to make sure it happens in a consistent and permissible and legal way? How are we going to make sure that the car makes the right decision when it's certainly going to have an accident about what to hit? Those are very big questions, and we don't have good answers for them today. We have a lot of people working on these answers, but they're not all working on the same objective. They're kind of working in different problems. I study martial arts. I study Kung Fu. And one of the things that you learn is how to fight in the dark. And if you get good at it, you'll hear music. It's a pleasant music. So when you first learn to fight in the dark, first of all, Kung Fu is really about not fighting. Does anybody here do Kung Fu? So I apologize, I'm not trying to make it about fighting. It's about not fighting, but knowing what to do, right? And when you learn how to fight in the dark the first time, it's a pretty advanced thing. You don't do it pretty advanced, right? You go into a dojo, and they walk out all the windows, and they shut the lights, and somebody goes in the middle of the circle, and they get attacked. And the first time this happens, you know, nobody does anything because they're like, "Are you serious? Like, you know, somebody's going to get killed here. Like, we can't do this." And then the instructor goes in the middle, and he proceeds to defend himself against 4 or 5 people very effectively. And then he turns on the lights, and he says something like, "Well, what did we learn?" And most people just learn how to get kicked or something because you're very ungraceful in that scenario. And eventually what you learn is that in the dark, everybody has the same disadvantage. And if somebody tries to hit you, they usually hit you pretty ineffectively because they don't know where you are, but they make contact. And as soon as they make contact, you know where they are, and you can much more effectively return the favor. And so it becomes a process of giving and receiving information. You're all trying to do something different in an environment which is inherently difficult to operate in, but you can learn how to do that. And by the end of that night, when you learn how to fight in the dark, you feel like Superman. You feel like you can do something that was impossible. It's not impossible, you just have to think about it differently. This situation is like fighting in the dark. There's all of these crazy forces going on. We can't see them all. We don't understand them all. They're all happening at the same time. We're ineffectively responding to all of them. But if we learn from each of those interactions, we get better and better and better. We can do that faster than the next guy, and that's how you win in a situation like this. Since we have a room full of innovators, I wanted to talk briefly about innovation. We usually think about innovation as building new things, new products, new services, new capabilities, and that is a type of innovation. But it turns out that if you take the words things and ways and old and new and look at all the combinations, so I just talked about doing new things in new ways. What about doing old things in new ways? Well, that's fintech. What about doing old things in old ways? Well, that's called dinosaur, right? What about doing, I forget which ones I did, but anyway, you get the idea, right? Sometimes innovation isn't just building new things. Sometimes innovation is progressive decomposition, taking a very large problem and breaking it down into smaller problems that we still haven't solved. That's a type of innovation. Cancer research is like that. Sometimes innovation is not for good, right? There's a lot of things going on with cryptocurrency right now that involve money laundering and human trafficking, and so we shouldn't assume that all innovation is a good thing. The opportunity cost for innovation in the wrong direction is that you started to do this and you should have been doing that, and by the time you go to do that, that has changed to that, right? So it's very important as innovators that we don't just say, we're going to disrupt, we're going to innovate, let's go innovate. Let's innovate together. Are you innovating yet? We have to have these sort of higher level conversations about what's the problem we're trying to solve, by what right do we solve that problem and not some other problem, what makes us credibly believe we can make progress. All the things we all learn in science have to be applied to data science, or we will just run around and do stuff. And this is a Red Queen problem, remember that. So if we just run around and do stuff, there's no guarantee that we'll make progress. We might accidentally trip over something important. A lot of startups are like that. Let's try this, let's try that. About half of startups try something and just fizzle out, probably more than that now. So thinking about how we innovate and what we call innovation and what it really means, and defining it in your organizational context, before you set out on a program of innovation, or have an innovation lab, or anything like that, maybe it's helpful to define what innovation means in the context of the organization that you're in. Since we are all, to some extent, very knowledgeable about AI in this room, I thought it was worth putting up a slide to talk about innovation in AI. Now, AI is an interesting term. Raise your hand if you think you understand what AI means. Everybody raise your hand. Everybody raise your hand. You know what I'm talking about, right? Now raise your other hand. Right? Now breathe in. I'm sorry. Okay. So, don't look. Okay. I don't even know how that happened. Why do we have that button? So, it's from a Disney movie. So, if you look at all the definitions of AI, they include things like mimic human behavior, mimic thinking, project human intent, advise humans, behave intelligently, behave rationally, behave. Those are all definitions of AI that I found in the literature on AI. Well, how can it be all those different things and be the same thing? And the answer is because we need a new word. There's nothing intelligent about artificial intelligence. Artificial intelligence is largely either regressive methods or reinforcement methods or unsupervised methods that do some sort of either regression or recursion in order to achieve some sort of goal function, which may or may not be modified. That should be the definition of AI. No one would like that definition. But if you listen very carefully to what I just said, let's unpack that a little bit. Machine learning, which is a part of AI, right? Machine learning's been around for a very long time. And for most people, what machine learning is it's supervised learning. Give me a whole bunch of data, give me some type of goal function, push the button, come up with the most important attributes, and keep doing it, right? Brilliant. Great idea if you're trying to study like drug interaction over 10 years. Great idea if you're trying to figure out how to change the acoustic properties in a room and you don't really understand all the influencers and you want to figure out which parameters are more important. There's lots of places where that makes a lot of sense. Why would you use a regressive method like that to figure out what's going to happen when GDPR becomes law in May? It's never happened before. All of the longitudinal data does not describe the environment into which you want to project your study. Now, can you use a machine learning algorithm to try to regress around some goal to study GDPR? Sure you could. Does it make any sense? No. So there's another type of machine learning, unsupervised learning, where we don't have, strictly speaking, data to go look at. We're creating the data while we're executing the method. So think about like deep learning, deep belief, things like that, right? Convolutional neural networks, trying to figure out what a dog looks like by looking at a whole bunch of pictures. But I don't really have like a canonical model of a dog because there's all different types of dogs. Those type of methods, which are more constructivist, are very useful in an environment that's changing while you're studying. Reinforcement learning is a third type of machine learning. Reinforcement learning is where we watch the human user for a bunch of functions that mimic some sort of success or failure, and then we converge around pleasing the user effectively. So think of cognitive computing. Think of an advisor sort of walking along next to you and saying, why don't you do this? and then watching what you do and deciding whether or not to advise you differently next time based on what you did last time. If you have a group of similarly instructed, similarly incented experts who you can watch, these sort of reinforcement methods work really, really, really well. That's how AlphaGo got designed. Super cool. Now, when the next one after AlphaGo, the thing that beat AlphaGo, I forget what it's called, can now beat it, consistently. Does this mean computers are smarter than people? No, it means they're better at playing Go. Okay, I'll play chess. Like, I don't care, right? I mean, it's interesting, it's great technology, it's amazing, it teaches us a lot, it brings a lot of awareness of the human race to what's going on in AI, but we shouldn't then give up and say we're dead because some computer beat a really smart human in the thing that the human was supposed to be good at. That's one thing that one human was good at. So all of these different methods that we have in artificial intelligence, and some of them geared toward what's called neuromorphic methods, behaving like your brain, even though we don't really understand the brain. Fascinating, 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 fascinating. Keep going, keep paying attention, keep getting better at all of this. But let's be honest, a lot of these methods have been around for many years. Nothing new just happened with AI. AI is getting better because we have more data and faster computers. Sorry, there's a few new methods coming out. But the vast majority of advances in AI today are because we have new data, lots more data, and faster computers. So there's no reason to panic. There's every reason to take advantage of AI, but AI is not really inherently intelligent. We shouldn't use human terms to describe computer processors. The problem is we don't have other words, so we use those words. And this is, in my opinion, there's people who disagree with me. This is exactly what I was just talking about, by the way. So here's I like to look at really smart people that are saying things and sort of quote them because it makes you look smarter, right? This is a really good guy, and he's talking about machine learning, and look what he did. Supervised learning, unsupervised learning, reinforcement learning, and then within unsupervised learning, he's got clustering, and he's got dimensional reduction, and within supervised learning, he's got regression and classification. Does that sound familiar? Because I just got done talking about it. Right, so there's lots of people talking about this in lots of different ways, and we can look for very clever ways of sort of putting this out. For those of you that are principal researchers and you have people in your labs doing machine learning, not a bad idea to put this poster up and say, well, when you said machine learning, which machine learning are you talking about? And why are you over in that part of the diagram and not down in this part of the diagram? And if they can't defend that, maybe they should stop pushing the button and start challenging why they're pushing that button. This one over here is another word cloud that I did thinking about AI. So when I think about AI, what do I think about? Well, I think about training methods, I think about time, I think about people, I think about negative implications, bias, human interaction, provenance, where did the data come from, veracity, how do we know it's all true? If you put false data into a learning algorithm, it will learn false things, right? Reproducibility is a big deal right now because the explainability of some of these neuromorphic methods is very low. They get really good answers that we love, but they can't explain how they got there. Well, that's a big problem if you're trading stock and somebody wants to sue you because they lost a lot of money. That's a big problem if an airplane crashes, right? So this is kind of where the state of everything in that space is right now. And this is one of the blogs I did around what do we mean by learning. I wasn't intending to promote my own blogs, I just forgot to put it up there. This is another frame that's very useful for really smart people like you to use when you're talking to other really smart people. This is a change leadership paradigm, right? If you want to change something, you need to think about people, process, technology, and mindset. If all of the conversation is only about the technology, you're probably not going to do well. Because you haven't thought about the people and how they adopt that technology. If you're only talking about the technology and the people, and you're not figuring out how you create sustainable processes, you're still going to have a problem. And similarly, mindset. If the people are, for example, not receptive to it, or if communication is failing, or if there are opposition, So in a data-inspired organization, in each of these quadrants, we have sort of a from and a to. So if you think about technology, for example, you'll see that you move from early adoption to integrating it fully in your value chain, right? So if the organization is using AI, but the AI is not integrated into the product design, and then later on it is, well then that's evidence of progress in that dimension, right? On process, moving from ingesting data to curating data, putting like with like, making sense out of it. Data lakes, there's lots of organizations that spend a lot of time pulling a whole bunch of data into these giant data lakes and then they can't find anything, right? Well, that's because you have an ingestion process and no curation process. You didn't think about how you were going to use it and find it. For people, moving from an analytic focus, which is basically doing a bunch of math, to a holistic focus. What does it mean? This is the conversation about how many businesses there will be in China, right? And then over here in mindset, focusing on the data to focusing on what the data means. So this might be a little bit of understanding when we see an increase in crime in a certain sector of identity theft. Is that increase in crime because there's some weakness in some code? Or is that because there's some advantage to be gained that is greater in that area? Is it because there is some, WikiLeaks thing? We have to understand what the drivers are. We can't just understand what happened and run and fix it. Because if we just run and fix it, it's going to happen again the next day, probably 10 times greater. This is another way of thinking about it. And I think this is a useful model. You should fill in whatever you want in these three areas here. These are what I filled in. But you might have different words on your chart. So if, in fact, the leaders, now this is focusing on the leaders of the organizations. If the leaders are evolving, then we should have some empirical evidence that there's evolution taking place. So in the early stages, and probably if we tell the truth, many of us are in these early stages, there's some degree of feeling overwhelmed. There's some degree of saying, I don't know what to do. There's so much happening here, right? It's helpful to recognize that that's an appropriate place to start this journey. Awareness of a skills gap, realizing that we need people that understand this new environment, or we need people that can do this type of, neural network, or whatever that is. That's important. Silos of evolution, where you realize that maybe the capability, the analytic capability in the organization is siloed, it's federated, it's they're doing it over there, and they're doing it over there, and they're doing it over there, and they're not doing the same things, right? That's pretty normal. As we move down into the emergent mindset, where the organization, the leaders in the organization are becoming more mature in how they think about data, you start to see things like skill shift from tools to competencies. We stop talking about Python and R, and we start talking about heuristics and truth, right? So I don't care what language you use. I don't care what tools you use. I care what you're doing with it. More focus on governance, provenance, security. So up here, there's a lot of focus on just getting stuff. And then as you mature, you start thinking about, well, wait a minute, how do I know I'm allowed to have it? How do I know I'm allowed to use it? How do I know I can use it in that way? Very normal. And then when we get down here, where we're really in a mature leadership mindset to lead this kind of technology-driven change, we should be reflective leaders who constantly reevaluate, constantly learn. I say this all the time. My personal philosophy is to teach something and learn something every day. If you're only teaching, you're becoming irrelevant. And if you're only learning, you're selfish. You have to do both. So when you asked how many people in here are students, I raised my hand and you laughed at me, but I meant it. Database decisions evolve through new methods and new learning. We can't just keep doing the same things over again. So this is a nice way of thinking about yourself as a leader and whether or not you're moving forward and where are you in your continuum. And finally we get to the future, just in time. So how do we create this mindset that evolves? And what advice would we give for thinking about the future? The first thing is we have to ask new questions. We can't keep asking the same old questions. How do we grow? How do we protect ourselves against disruptive innovation from China or Russia or pick a country, it doesn't matter. How do we stay relevant in smart cities? How do we stay relevant in, give me three more. I know there's 5 plus 2. Right? How do we stay relevant in all of those things, right? Great questions. But if you were asking those questions 6 months ago, maybe ask the next level down, right? So if there's going to be an internet that is not like the internet today, what can I do then that I can't do now? Which is a different question, right? If I have all this data that's locked up in silos because I don't know how to use it permissibly, what will I be able to do when I can use it permissibly? If I see competition coming in the technology space because we're good at making stuff, but we're not necessarily good at integrating stuff or making that stuff do new stuff, what would happen if we could? And how would we know that's happening? So those types of questions are evolutionary. And these are really good questions to ask. These questions go back thousands of years. What do we know? How do we know it? And what has to remain true in order for us to keep doing whatever we're doing? Those are critical questions. I ask them all the time. When somebody is coming to me and they're saying, look, we need some new analytic approach to looking for, I don't know, small and medium enterprise business growth in small Middle Eastern countries where there's not a lot of data. Okay. What do we know? We know that small businesses fail faster than big businesses. We also know that they start more quickly than big businesses. We know that their identity changes, about 50% of it changes in a year. We know that it's the most volatile. We know a lot, right? How do we know it? Well, we've been collecting this data for 175 years all over the world. We see these trends. This is when it's totally appropriate to use a regressive approach. Not only have we seen these trends, we've seen these trends survive through wars, through leadership upheavals, through coups, through all kinds of business disruption and innovation. So we understand that there's a reasonably credible argument that those trends will continue. What has to remain true? Well, it has to remain true that we define a small and medium enterprise in the same way, that a business is what a business is. It has to remain true that they leave some sort of trail that we can see, right? If they start going into cryptocurrency and fintech and all of these other things, they become more invisible. So maybe I have to challenge that. So that's just an example of the types of questions that informed sort of new age leaders ask in this environment where you've got all the AI you want, you have all the technology you want. If you're like anybody else, your problem isn't that you don't have enough data or you don't have enough technology. It's that you're struggling to figure out how to integrate it into some challenge that you have. Everybody's dealing with the same thing. And I have another 4-factor thing. So what I did was, if you remember the chart that I had before that started with mobile, social, cloud, right? Those are, I don't think social was on there, but mobile, cloud, those are sort of the traditional drivers. Today, I think the drivers are artificial intelligence, Internet of Things, social changes, and modern workplace. Those are what I think are the 4 big drivers of change, disruptive change, and innovation change in enterprises today. And then what I did was I went over here and I said, well, excuse me, this is an exercise I like to play with my team. Spin the wheel, right? Pick one. I'm not going to talk about them all, right? So let's pick artificial intelligence. Right? You can't just say artificial intelligence and move on, right? You have to think deeply about it. So we've talked about explainability. We haven't really talked about ethics, but that's really important. We've talked about autonomy. You have to fill this box in. And then once you fill this box in, then you have to start understanding how your strategy is changing as a result of that change that you see up there in that driver of change in the context of all these other drivers of change. The problem is if you don't do this, if you just go in tomorrow and do the same thing you were doing yesterday, the cost of doing nothing is not nothing. The cost of doing nothing is that the bad guys get much further ahead much faster, competition gets ahead much faster, and you become more irrelevant more quickly. So it's really a good exercise to make a wheel like this from your own perspective. I think these are the right 4 corners. But to fill in what the issues are over here in each of those 4 corners from a Taiwan perspective would be a really, really, really valuable thing to do. And a great place to start sort of making the argument for why you're focusing where you're focusing. Some of the things that are sort of on my radar for the future, these are the areas where in my laboratory we're doing innovation. Definitely artificial intelligence, fintech, blockchain, privacy and regulation. We talked about quantum computing. We talked about the Internet of Things and autonomy. Cyber X is anything that starts with cyber. Cyber security, cyber terrorism, cyber enabled, things like the dark web, anything that starts with cyber. So if I don't have some level of thinking and some level of testing and some level of proof of concept and some level of development going on in each of these areas in a context that looks kind of like that, then how dare I claim that we're doing groundbreaking research? I might be just doing enough to keep the doors open. That's a really bad thing to do. And then finally, we get to this concept of learning from our mistakes. We all talk about learning from our mistakes. And sometimes, if we tell the truth, we just get better at making those same mistakes. We have to make new mistakes. It's okay to make mistakes as long as we're making new ones. So some of the areas where I see the same mistakes being made over and over again that I think we should pay more attention to, one of them is observer effects. Really, really important. The idea behind observer effects, we all know about this, is that when you observe something, you change it by the fact that you've observed it. So let's think about fraud. If I have a whole bunch of data, and somewhere in there is suspected fraudulent activity, and I'm going to use some sort of AI or some sort of methods to go and look at that data and try and find the bad guys. Well, the best bad guys, when they know they're being watched, the first thing they do is they change their behavior. So if I try to model bad behavior, I'm going to be modeling how the best bad guys are no longer behaving. That's an observer effect. And I see time and time again people using data where their observation changes the thing they're observing and forgetting to account for these observer effects. There are ways to solve a problem like that. We probably don't have time to talk about them here. We call them black cat problems. It's like looking for a black cat in a dark room. It's hard for people to find the cat. They can't help each other. The cat is black. The room is dark. It might not be there, right? There are techniques for dealing with these black cat problems. And we can talk about them offline if you like. Some really exciting things. I won't talk about all of these, but legislation lags evolution. No matter what we do, the best legislation will always talk about yesterday's technology and maybe some projection of what we assume the future technology to be. But the reality is that the people creating the technology will, if they don't like the legislation, will just change the technology so that the legislation doesn't apply. And then we get into this, back and forth kind of behavior. And you see this a lot. You see this right now with drones. You see this right now in autonomous vehicles, and you see it to some extent in biomedical. Some of the biomedical devices in terms of security and so forth. So, what are we going to do about that? The answer isn't to get around the law. The answer is to understand what the lawmakers are trying to achieve and to have a voice as scientists in the creation of those laws so that they understand the impact and that they write the right regulation and that we're good stewards of that regulation and that we observe it, but we do it in a way that's more of a working together as a community. And then the last thing I would say, I want to talk about all of these, but I want to talk about this last one. We talk about best practices a lot. Almost every organization has some document that describes best practices. And then if you watch the way the people in the organization are behaving, they're not using those best practices. They're not retaining knowledge when people leave. They're not recording when they stop doing something, the reasons why they stopped, so that when they come back later, they can understand it and maybe understand why the conditions have changed. A lot of best practice is just to make somebody happy, some project manager happy, that we filled in a document. And if we don't get better at that, then we will continue to make these same mistakes much faster, with much greater and much more global impact. So I'm going to leave you, when we go to questions, I'm going to leave you with two quotes. I usually try to end with a quote that inspires me in that day, so these change a lot. This particular day I was inspired by Bill Gates. I think we all know who he is, right? Never before in history has innovation offered the promise of so much to so many in such a short time. I think I've been saying that, right? But then look at this one down here, same person says this. Information technology and business are becoming inextricably interwoven. I don't think anybody can talk meaningfully about one without talking about the other. If we don't understand technology in the context of business and business in the context of technology, we will become victims of both. Thank you very much.
Thanks for the Dr. Scriffignano's great talk, which is full of insightful ideas. And he would like to, he's okay to take some questions from the audience. So, any questions?
Please don't be coy. Please ask questions.
Hi, Anthony. I see the content as you mean. Before last time, I see the quantum computer is around 10 years ago. So at that time, we all doing some high performance computing, which is leveraging a lot of computing to do some science testing. And now, do you think for the quantum computer will accelerate the AI or our technology to facilitate our technology in the future?
So I'm just going to repeat to make sure I understand the question. You've been watching quantum computing for about 10 years, and primarily in the context of high performance computing. What about AI? That's your question, right?
Yes.
So, until quantum computing came along, there were only two ways to make things faster. And high-performance computing basically uses both of them. So the two methods are write a better algorithm or break up the process into a whole bunch of other smaller processes and try to do them all at the same time. It's called parallel computing. And basically, those are the only two ways you can make things faster in a digital computer. You write a better algorithm, or you break up the process into multiple. You can get faster equipment, but you still have the same problem tomorrow, right? Quantum computing, you can make things faster in a different way, because the type of algorithms in certain problems, not in every single problem, but in certain types of problems, especially the problems that involve decay, some of them can be done effectively in an instant because they're done in hardware. Some of them can be done orders of magnitude faster. So we talk about the algorithms that are sort of easy, and then algorithms that are NP complete, non-deterministic, polynomial complete. We can't calculate how long they'll take until they're done. And then we talk about intractability, which are the ones that we really can't do, right? If you think about quantum easy and quantum NP complete doesn't really work, but quantum hard, right? Where quantum easy overlaps NP complete, there's some really exciting opportunities there. Really exciting opportunities. And those are the ones that we want to focus on first. AI is not in that category. So does that mean we shouldn't use quantum computers for AI and that there will never be quantum AI? No, of course there will be. I don't think that that's the best first thing to do. I do think that before both of us retire, that will be happening. The types of problems where quantum might help AI is in pre-processing information. So think about like computer vision, understanding, is this a dog or is this not a dog? Today we have to do that by looking at eigenvalues and all kinds of complicated convolutional neural networks and really difficult stuff, right? And it takes a lot of time. So it's very hard to build a car that will say, there's a dog, because it might take 5 minutes to figure out that it's a dog, right? Even with really fast computers. It's possible that quantum algorithms might be able to reduce the complexity of a problem like that, which is very well understood, and contribute to AI, I don't think we're going to see end-to-end AI solutions in the quantum space for a long time. I might be wrong by next year, but that's what I think. Okay? Thank you.
Any others? Like big data.
Yes. Just the lady in the middle.
Hello, Dr. I'd like to invite your opinion about the topic of blockchain. The first one is how do you see blockchain technology is going to impact the global banking? I think you know a lot about it. Very interesting to that. And the second one is about blockchain startup. Because IBM has developed blockchain technology for many years already. And right now there are a lot of blockchain startups. Do you think they are able to go to anywhere? Okay, thank you.
So the question is about blockchain and how blockchain will impact banking,
Yes.
and whether or not, is it real or is it just a hype? Is that?
Yes.
So it's real. It's definitely transforming the way bankers think. Every single bank in the world right now is thinking about the impact of blockchain. So there's not one simple answer to that. I'm going to give you sort of the arguments that are in favor, and then I'm going to give you the arguments over here, right? But don't make me argue about these, because there's a lot of argument, right? This is how I see it. So the arguments over here in favor of blockchain are, you know, with a distributed common ledger. So the idea behind, let me back up, for everybody here, in case you're not an expert in blockchain, the idea behind blockchain came from Bitcoin. They needed a way to distribute Bitcoin that allowed everybody to seamlessly exchange Bitcoin. And this blockchain technology was originally invented for that purpose. And then a bunch of people started to figure out that, well, gee, we can use this for other purposes. We can build smart contracts that allow different people to engage and work with each other. We can build sort of end-to-end transparency in an ecosystem where people are doing business with each other, and allow that to happen virtually. So it's not in any one computer, it's out in the blockchain. How did I do? Okay? All right. So if you're a bank, you have a lot of laws that you have to follow. And now I'm going over on the other side, right? Some of those laws were never written to involve blockchain. If you're a blockchain startup and not a bank, sometimes those laws don't apply to you. So some of the fintech companies that are using blockchain technologies, for example, to accelerate credit settlements, can possibly do it in a much more efficient way than a bank could do, because the bank has to follow certain rules around KYC and around anti-money laundering, things that apply differently to this startup that's not a bank. What I think you will see happen over time is that the definition of bank will change. And so, yes, blockchain will help banks, but not these banks, those banks that they're going to transform into. There are still some big challenges in blockchain in terms of performance. There's still some big challenges when wrong information gets into the blockchain of how you correct it. And the fundamental problems of knowing who the counterparties are, and fraud and all those things, don't go away because you have blockchain. There's an illusion that those problems go away. They do not go away. They're still there. And so blockchain might actually accelerate that. And then, if I take this gentleman's concerns about quantum computing and I connect them to your question about blockchain, blockchain is fundamentally safe as long as encryption is very hard. And when quantum hacking comes along, encryption won't be so hard anymore. So we're going to have to figure out how to do quantum encryption, and I don't think anybody knows how to do that yet. So it's not a guarantee. It's not going to go away. It's too big to go away, but it's not going to be what it is today. It's going to be the third generation of what we understand today, and this will be the same thing for banks. And honestly, if you think about what a bank is today and what a bank was 20 years ago, it's already different. Who goes to their bank anymore? You don't actually go to the bank, right? So most people don't. So banking has been constantly under assault and transformation. I think that's just going to continue. Blockchain is one of many forces that is causing it. It's not just blockchain. There's a lot of other things that are driving the change in the banking industry. Blockchain's one. I think you had a question.
It's a wonderful talk. I know that there are lots of opportunities now, but because there are so many opportunities, but you know, Taiwan is a small country. We have a limited resource. So I don't know if you have any opinion about, you know, the direction or the ways we should do. For example, we don't have that big market. So if there are some business we would like to grow, unless we can grow through the, you know, other countries. But for example, if this is a very high potential, it's sometimes it's, you know, at least my opinion is, some of the countries, they have the protection so that they will support their own business. So it's hard for us to go through. So I want to know that, do you have any suggestions to Taiwan about the direction or what kind of the the suggestions so that the direction or certain kinds of properties of the development is more feasible for us to grow and eventually will be accepted by the whole, the whole universe.
Okay. So your question, because there was microphone issues. I'm just going to repeat what I heard. Taiwan is a small country. I don't know that it's really a small country, but it's a smaller country than the one to the north, right? The issue is where do we focus?
Yes.
And how do we stay relevant when all this change is going on around us? Now, sometimes, I'm going to go back to martial arts for a second. Right? Very often, the big guy loses because the big guy has a lot of mass, and it's hard for the big guy to move and change direction, right? And the smaller person can be very agile, and the smaller person has certain advantages going into a situation because of their perspective. They can see things differently, right? So if I were here in Taiwan trying to drive technology advances, I would look at what resources do we have that make us unique. And there's a few things that you have that make you unique. You have a strong base in technology manufacturing, kind of hardcore technology manufacturing. You have pretty much every major high-tech company has one foot here. There is a stable banking environment. There are seaports. There's a whole big Belt and Road thing going on that's dramatically focused on sea, right? So what kinds of innovation enable integrating new technology into an expanding environment where commerce is more connected? Well, the Internet of Things is an obvious example. The Internet of Things is an open field for almost any, it knows no boundaries, it knows no borders. Anyone who is not paying attention, not to how do we make new smart things, yes, we need to do that, but how do we get these things to talk to each other? How do we develop standards? How do we create an environment where they can discover each other and use each other's information in a permissible way? How do we control the cyber threats that come from doing that wrong? How do we protect intellectual property? How do we secure infrastructure? There's no reason why any of that can't happen in Taiwan. If you look at blockchain, if you look at, not so much quantum computing, but if you look at blockchain, if you look at artificial intelligence in general, there are so many open fields right now for innovation that it's really about picking the wrong one as more than it is about not picking one. So where's the economy going? Where are small and intermediate enterprises starting up? What industries are they in? Certainly, you have very large percentages of the population here that are in a small number of cities. Every single major city in the world right now is trying to back up and fix all the pollution problems that they have. You don't have that problem here in Taipei the way they have it in lots of other cities around here. So you have a great opportunity to be pioneering some of these smart city, green city technologies. The ASEAN countries that are developing and growing are right around in your neighborhood. What are some of the technologies that help deal with the marginalization in fintech, for example, money transfer and micro lending and all of that? Well, there's unmeasurable markets there for that. So I don't see an absence of opportunity. I do see I see a presence of risk, I get it. I'm not saying it's easy, but when has this country ever done anything easy, right? So I don't think it's hopeless at all. I think there's lots of opportunity. I'm not sure I answered your question based on.
Yes, I want to know that is there some duration that is. What you're talking about, I agree. Lots of the opportunities. But are there some duration that we may not be suitable to focus, or is there some guideline?
I probably wouldn't try to corner the market on quantum computing. Let other people do that. You know, it's really expensive, and some other people are really far ahead. I wouldn't worry too much about that one. They're all doing it in the cloud anyway, so when they're done, you can use it. Cloud computing, you know, that's kind of yesterday. Cyber security, I don't think is a Taiwan problem or a Russia problem or a US problem. I think it's an Earth problem. So I think you should be part of that dialogue. In terms of regulation, you know, I think you got to be careful. If you issue regulation that's too strict, then you create an environment where it's very hard to innovate, because it's very hard to share information across borders, and it's very hard to, at the same time, people want privacy. So I think you should, you know, there's a tendency to just take some other law from some other country and copy it, and don't do that, right? Because the environment's different here. It's a good opportunity to do that better.
I have a question. But now IoT, the standard, the standard of the communication, even though we can set up the standard, but it's hard for us to let the standard be accepted by worldwide. So
everyone has the same problem. I'm sorry, I interrupted you.
I mean the standard for the communication in the IoT, it seems it's hard for us to set up a standard and being well accepted by the country. But when we are developing that, sometimes the standard, communication protocol standard seems that's one issue because.
Yeah. So if we look at Bluetooth as an example,
yes.
Bluetooth came around, and there wasn't an open standard for Bluetooth devices that was universally accepted. It took 10 years because of all these stupid things, like what happens if my headset discovers your telephone, you know, and then I can listen in on your conversation, and how does the software switch so that you know that that happened, and all of those things. The technology itself, the concept, was out, and then because of an inability to share among manufacturers in a way that was standard, I don't know that a Taiwan IoT standard would be the answer for the same reason, right? Because then somebody else will come out with another IoT standard, and then you'll have two standards, and then you'll have a third standard, and then there'll be white papers talking about which standard is better, and 10 years will go by. So, you know, this industry, we have some very large players in this industry. Some of them have offices here in Taiwan. I don't know that the government could necessarily come up with the right standard, but I'm pretty sure the government could create an environment that makes it advantageous to the industry to adopt something, there are organizations already that exist today that are, I don't want to start, there's some politics here that I don't want to get into, right? I think you have to be thoughtful about this. I'm not sure that just naming an agency and giving them the job of creating an IoT standard is the answer. They'll spend a lot of time, they'll develop something brilliant and incredibly complicated, and then it'll be up against something else brilliant and incredibly complicated, and they'll do different, and the whole world suffers. Right? And then you can only use IoT devices within one manufacturer because they're all using the same standard. Right? We gotta be better. We've gotta be better. I'm not a standards guy. I'm one of the people that suffers from the lack of, I don't know if you're, I'm gonna guess that you're not, I'm old enough to remember EDI. EDI was electronic data interchange. It was before the internet. And there were ISO standards for every single type of commercial transaction you could imagine. Issuing a purchase order, shipping goods, advanced payment notification, functional acknowledgement. There were all these different standards. And these standards got more and more complicated and more crazy. And if you wanted to do business with a company like Walmart or I don't know, pick a big company, General Motors, you had to use EDI. So most small companies didn't have the capability to understand and adopt all these standards, so they started paying other companies. And so you had software that was designed to transform your data into the other standard to communicate with the company. But then there was more than one standard, and then people started to use the standard methods to do non-standard things. So like, how does a law firm put services into a contract that's designed for parts? So they start using the standards in ways that they weren't intended. It was a mess. It was an absolute mess. It was a nightmare. There's still EDI in use today in certain applications, and now we have an internet, so we don't really need that kind of capability. My whole message here is, can we please make a new mistake? Like, can we please not make that mistake again? I see us moving down the path of Bluetooth. And everybody's just saying, yep, yeah, we need a standard. I hope they get one soon, right? I think I know what's going to happen if this doesn't get more serious. There's going to be some very major cyber bad things happening. A third of the internet was taken down not too long ago in North America from a denial of service attack that involved devices that were cameras that we can argue are part of the Internet of Things. What was the cost of that outage? What was the economic impact of that? What happened to hospitals when people were in surgery? What happened to, airline scheduling? I have no idea what the cost of that was. Could we please not do that again, right? I don't see anything really happening other than everybody saying, yes, that's a big problem. I guess I'm doing the same thing right now, but I'm using bigger words. So. You're right. I don't think it's a Taiwan problem. I think it's an Earth problem.
I really like today's speech.
Thank you.
And I say the most difficult part is asking the right question.
Totally agree.
And asking the question is back to education.
Yeah.
And education still is a big problem. If I'm looking at my kids, they're still doing the same old thing as 20 years ago.
Except now they have a 9-second attention span, right?
Exactly. So they are a totally different animal from my point of view. So I'm saying that the data scientists, have you ever any program like looking at the generation,
yeah,
how they learn,
yeah,
and totally different from my generation.
Absolutely.
And if we can understand the learning, then definitely we can teach them critical thinking, and then they will solve the future problem. So all back to the education. So that's my only concern, that people care about technology, blah blah blah, but about the education, how data scientists can help.
Yeah.
Helping them with our future education.
I totally agree with you. You sound like a wonderful father. I'm the crazy uncle, right? I have lots of nieces and nephews, and when they're 6 years old, I'm teaching them advanced data science topics. I just don't tell them. Right? I have a 5-year-old great nephew that can tell you what a non-deterministic outcome is. I had the father of that 5-year-old is my nephew, so he's my great nephew. The father is an engineer. He's a really smart guy. I almost said kid. He's not a kid. He's a father. Right? But he's young. And he's very smart. He's taking calculus. He's smart. He's an engineer. And I was driving in the car with him one day, and I said, you know, I had this conversation. I said, everybody always says, well, when I went to school, it was different. Of course it was different. But I said, the thing that I worry about in your generation is you not only don't know how certain things work, you don't care that you don't know. And he said, well, you're probably right. And I said, do you have any idea how to calculate a square root? There's no formula, there's a process, right? Do you know how to do that? And he said, nope. I pushed the square root button on my calculator. And I said, well, what if you didn't have a calculator? And he said, everything has a calculator. My phone has a calculator, my calculator is a calculator. There's calculators everywhere. I said, well, what if you were on a desert island and there was no calculator? And he said, then why do I need a square root? He doesn't care. He just doesn't care, right? So instead of me trying to make him care, I have to address, does it matter that, it's what Bill Gates was saying, right? Does it matter that we're losing awareness of how our things work and why they do what they do? I think it matters a lot. And I'm going to fight until they kick me out of the room that some of these fundamentals of understand, you don't have to understand every nuance of blockchain and how the but you do have to understand that that nuance is there and that it's doing certain things and that it's not doing certain things. And we do have to have the ability to understand a little bit deeper than our 9-second, you know, where's the app? And if we don't, then we're stuck on the side of the road and the car won't start and we have no idea why. And we have to wait for the guy to come, right? And that guy is going to come from some developing third world country where they do care about those fundamentals, right? And maybe that solves your problem because they'll develop the standards, you know, in some very small country somewhere. You know, there's a lot of teachers in this room. I think there's a lot of teachers in this room. You're either actual teachers or you're, you know, PhDs, and by definition, you're expected to add to your field. Add this to your field. Critical thinking, understanding fundamentals, realizing why things work and why they're set up the way they're working is much more important than the next programming language. Yes, you need that, but this will kill you. Couldn't agree with that. Why does we no microphone?
Thank you for the inspiring talk and very thoughtful. Yeah, I think in the future world, or nowadays, actually we're living lots of like a raccoon syndrome, and technology changes a lot. And I believe in the future there'll be even more uncertainty, right? So I just want to ask you, so what's your approach, your process to ask the right question as a data scientist? And also, how do you approach when you keep in the dark?
Okay.
Because I think that will be very, very useful for any situations that we will face.
Great questions. So the question is, okay, smart guy, how do you ask the right question? Right? And okay, Kung Fu guy, what happens when you get kicked in the dark? That's what you said. You said it nicer, right? So I'm going to be honest. I started out my education in physics, and I was trained in the strict scientific method. So to me, data science means science. It means you start with observing the world. I've tried to demonstrate it here, right? You start with observing the world around you, and then you ask some important question. You refine that question until it can't be refined any better without departing from your observation. You go study what the people before you have done before you start doing something. You pick a method, you defend that method, then you collect your data, you analyze your data, you understand the deficiencies in it, and you try to answer your question, and you keep doing that, right? So, how do you ask that important guiding question? Well, first of all, you've got to realize how important that question is, because you're going to do all these things, right? If you start with the wrong question, you'll say, well, I'll tell you how many businesses there's going to be in China. That's not the right question, right? The right question is, how many businesses do I care about in the context of my customers and non-customers in the future state of China 4 years from now, will there be? Right? That's a much more complex question. So we have to look at what's driving you to ask this question. If you were to answer that question, would it actually satisfy that need that you have? When people go into a pharmacy with a headache, they don't have an aspirin deficiency. They have a headache. right? So you have to ask the question, if I took this aspirin, would my headache go away? I don't know, maybe you need more water, right? So I have a headache right now. What question would help me differentiate between I need more water and I need aspirin? Well, I haven't had any water today, right? A lot of times it's just about asking a more refined question and a more refined question until the next question doesn't make you any smarter.
Could you share your experience? I think maybe one case that
Well, the China one is, I think, a really good example. Maybe I can give you another one, because obviously that one, for whatever reason, wasn't. Someone came to me recently and said that they were working with a new customer. It was a very large organization, but they were not a customer of ours, which is actually pretty unusual. We deal with most of the big companies in the world. And it was a great opportunity, fantastic opportunity. We want you to come with us to meet with the customer because this is such a great opportunity. And I said, well, why is it such a great opportunity? Well, because they're such a big company. And I said, well, I get that they're a big company. That doesn't necessarily mean that this is a big opportunity. What do they need? Well, they've invited us to come and meet with them. Why have they invited you to come and meet with them? Well, because they don't know. So they don't like me when I do this, right? So they just come to the meeting. And I said, no, I'm not coming to the meeting. I'll come to the meeting when you can tell me why we're going to the meeting, because otherwise I might make it worse, right? So then they come back, they call the guy and they come back and, all right, fine, we have the answer. The guy we're meeting with is responsible for growing their business. And he wants us to help them grow their business. That's great. What does that mean? Well, they want to grow their business, and it's a really big company, and it's a great opportunity. And I said, okay, we're making progress. They want to grow their business. Does grow their business, I get grow their business probably means make more money, right? But there's lots of ways to make more money. You can sell more things to your existing customers, or you can find new customers that look like your best customers and sell the same thing to them. Or you can find new customers that don't look like your best customers and sell something different to them that you make more money on. Those are three completely different strategies. Which one are they interested in? I don't know. But now I have the beginning of an important question, because when I go to that meeting, I can start to probe around those three types of growth, and I can get to that critical question. Just saying come to the meeting because it's important is not nearly enough. And just saying grow the business is not nearly enough. But now that I have a model where I can probe in three different places, I can make that guy really happy that I came to the meeting, and he was. If I just went to the meeting, we're going to drink tea, we're going to talk to each other, we're going to say nice things, nothing's going to happen. I'm not going to help that guy, he's not going to help me. Everybody's going to be very happy because we had a meeting, and nothing happened. Does that make sense?
Yeah.
Does that help?
Yeah.
The kicking in the door. I get kicked in the door all the time. So the first thing, the most important, and this is a metaphor, right? I'm not talking about fighting here. But the most important thing when you get kicked in the dark is to learn from the experience, right? Most people's tendency when they get hit is to say, ouch, right? But how did you get hit? Where did you get hit? How purposefully did you get hit? From what direction did you get hit? Were there any sounds that came after that? All of that is information that you can use, right? So I'll give you the metaphor in Kung Fu, and I'll tell you how I do it in the organizational setting, right? Let's say there was somebody behind me that I didn't see, right? And they came up behind me and they hit me, right? My initial reaction, because I'm not ready for this, would be to take that energy forward so that they're pushing on nothing, right? Well, what happens when they push on nothing? They fall past me. Now I can see them, right? And now as they fall past me, I can bring my foot up and thank them for hitting me, right? So I'm not suggesting you do that. But in a corporate setting, right, if a competitor comes in and they, so that the equivalent of being hit from behind is we go to a conference, we go to like what do they call it, a trade show. And there's a big sign, we beat Dun & Bradstreet every time, right? No, you don't, right? But if I go over there and I say, you do not, and I start arguing with them, then I'm going to actually play their game. So maybe when that happens, I say, really, Tell me how. Right? Well, we're cheaper than you. That's great, you're cheaper. You're cheaper at what? The same thing or something worth less? Whoa, we're cheaper. I got that. You said that. Right? But tell me more. What are you cheaper at? Right? And then eventually, you know, the same kind of three-question thing turns into, well, you know, let them decide, right? So taking that information, right, and embracing it. If you say to me, you're an idiot, right? I don't become an idiot because you call me an idiot. If I say, well, why do you say that? What makes you say that? Well, I don't really mean that you're an idiot. I just mean that you're not listening to what I'm saying. All right, I hear you, right? And now we're sort of together. I almost said in Italian word, simpatico. We're working on the same thing together, right? So this being hit in the dark is about learning from this, not just getting offended, not just getting, you know, backing up, but using that information to move forward. That's the best way I can explain it. If we had a dojo here, I could explain it. Yes, sir.
Thanks a lot for great sharing on Jerry Chen. You mentioned about the black cat in the classroom.
Yes.
The cybersecurity.
Yes.
I was wondering how to solve this problem. And
Okay.
and second one is we keep on creative because we know how to do synergies and relate things. Is there any way that AI could answer?
Yes. So the answer is yes to both. First of all, let me say you never solve it. So this is about progressive decomposition. This is about taking a problem that is it's not even NP complete, it's intractable, right? The whole story is there's a blind man in a dark room and he's looking for his black cat, right? He doesn't care that the room is dark. He doesn't care that the cat is black. He just can't find his cat. Cats are hard to find, right? He asks you to come in to help him. And the reasons that it's difficult for you to help him are different than the reasons he was having trouble in the first place. So it's hard for you to work together. You can't see and the cat is black and you're focused on that and he just can't find the cat. But it's very hard for you to work together. So these finding fraudsters, finding new business opportunity, it's not always bad things, right? There may or may not be a new business opportunity. There may or may not be a fraudster when you go looking. So it's a black cat problem because the thing you're looking for is very hard to see. When you observe it, it often changes, and it's very hard for the parties working to collaborate because they all have different issues with the environment. That's what we call a black cat problem. So there are many techniques that we have found to be very helpful in these kinds of problems. Let me repeat, you don't completely solve them, you reduce the complexity. So one of the techniques, I'm sorry I have to use a lot of crazy language because there's no simple language. We borrow from biology. There's a concept called isotropism. When you slice an orange through the middle and you take multiple slices, every slice looks the same, but the slice itself is not all the same, right? So you have the orange peel and the orange part and the middle part. So there's it's not homogeneous. It's not like slicing a ball of clay, but it's predictable, right? So an isotropic region is a region where it's kind of all different in the same way. The opposite of that is an anisotropic region, a not isotropic region. And so using sparse graph analysis, we can take dyads, connected relationships that have different strengths, and we can build traversal algorithms. Some of them could use AI techniques to find these anisotropic regions. When we find them, we don't know that there's fraud there, but we know there's something different there. So we've reduced the complexity of the problem from trying to look at the whole system to now trying to look at this region. And then we watch that region over time to see if it changes. So if you see an isotropic region and an isotropic region form and dissipate, that's a really good place to go look for one of these black cats. That's an example of one of the techniques. Are you really sorry you asked me? Sparse graph analysis is the broad field that contains a lot of this, and some of this we made up. So, you know, we're on the edge of computer science here. This is not, there's no book on this. There are many other techniques. Looking at the character and quality of all of the information and how it changes over time is a simpler one. Right? Looking at all those V's, volume, velocity, veracity, variety, value, and seeing how they change over time. You know, when you start adding fraud to an environment, then it starts to become less useful for other things, so that would be a broad measure. There's many different ways to approach this. And then at the end, you need really smart people to look at part of the data with their human brain and clapping to figure out the last part of the problem. You don't solve it. You make it tractable.
AI and synergy. Great.
So the AI could be used, for example, to prosecute one of those techniques in a very large space. You might use a convolutional neural network, for example, to look at your sparse graph. It's very large. Just as an example. That's not what we do, but that's an example where you could use an AI. We don't use AI for that type of a problem. We use a bunch of algorithms that we throw into the same space and ask them to do the same thing differently, and then we let them compare notes. So it's more of a, it's called a blackboarding approach. But you could use AI, and we might in the future. Just, right now, that's not the approach that we use.
This is the very last question.
I'm glad we finally got into some like really geeky stuff. Thank you for the question.
Hello, sir. I have a simple question about the black cat.
About
Black cat.
black hat.
Black cat. Because the public or audience could not understand what data science could do. So let's say you are the problem solver. When you come here, everything will be settled down. So could you give us a recommendation for ABC of data science can do? Or paper or textbook
Yeah.
for children or anything? Thank you.
There is a very good book which I can recommend. It's called Data Smart. It's a really good book that talks about that. I could show you later. But, so the question is, I don't think you were talking about me in particular, but when somebody with the data science discipline comes in, people say, oh great, he's going to solve all the problems, right? That has not been my experience, by the way. My experience is they say, oh great, now we have to deal with him too. But you know, there are people who act like they're going to come in and solve all the problems. And I would be very careful with those people. If you see what we just did, was it Jerry?
Yeah, Jerry.
Sorry. I'm really good at I'm Anthony. So if that happens, right, so they say, all right, well, Jerry's here, he's going to solve all the problems, right? The first thing you have to do is be a little humble, right? And what I did was I said, look, we're not going to solve the problem. What we're going to do is we're going to take the problem from unsolvable and turn it into something really hard. And then we're going to take the thing that's really hard and we're going to break it up into smaller pieces and say, look here first and not there. And then we're going to let people solve that smaller, really hard problem, right? I didn't say I'm going to solve it. And if I said I'm going to solve it, he shouldn't believe me. Because I just got done saying that it's kind of unsolvable because it changes when you look at it, right? So we have to be very realistic. There's a lot of vendors that sell tools today where they say, I will tell you exactly what your most important data is. Just connect all of your data sets to my tool, and I will watch, and I will do metadata analysis, and I will tell you what the most important data elements are. And they will say pretty much the same thing. And the conversation I have with them is, that's great. How will you know what's most important? Well, we'll watch what you look at the most. And whatever you look at the most might be the most important. Do you believe that? Like maybe the thing you almost never look at, but you look at when something unbelievably important happens is the most important thing. So frequency of observation being connected to importance is a fundamental postulate there that I don't accept. It might be totally appropriate to do that watching emergency room physicians looking at what drugs they prescribe and say these are the most important. I don't know, I'm not a doctor, but it's certainly not appropriate in what I do. So if that guy then says, well, we understand that, but we have another way of looking at it, well, maybe we keep talking. Usually he goes away mumbling because they don't have an answer. So the bottom line to my answer to your question is, data science is not a solution. Data science is a mindset. And it's the data scientists of the future will be much more like the doctors of today. They're going to be looking at very complicated environments where they can't possibly understand everything. And they're going to form diagnoses, and they're going to test those diagnoses and try to understand what's going on in the system, just like doctors do today. This is going to become much more of a clinical practice and much less of a kind of practitioner approach over time. The best ones will be that way. That's my real answer. Okay, thank you.
Okay, before I end this talk, and I would like to invite the economic officers from AIT, Mr. Ryan Aben, to give us a concluding remark.
So thank you very much, Dr. Scriffignano, for that excellent talk. And thank you all very much for coming. As Jeff mentioned at the beginning of the talk, AIT is very much would like to be Taiwan's partner as it tries to transition to an innovation-based economy. The central policy challenge, the central economic, central technology challenge you all face is to innovate faster than China can catch up with you. And the people here in this room really are the leading edge for enabling Taiwan to make that transition. And so the way you think about things and the way you work will very much determine the future for Taiwan. And the United States very much cares that you succeed. A prosperous and successful Taiwan makes for a better US partner. And so we want to be there with you as you do this. Now, one of the questions that came up was, what are some of the areas that Taiwan might have some competitive edge in that it might be able to succeed in? Excuse me. So this is a question that AIT has been asking a lot as we consult with our industry and our business and our experts to try and figure out how can we cooperate with you. And so there's several areas that we've identified that we think are particularly good. The first is smart machinery. So there's a Stanford professor who said the internet over the last 10 to 15 years was internet 1.0. It was the consumer internet. But the internet that will be developed over the next 15 years will be internet 2.0, the industrial internet, where we essentially take the entire industrial process, connect it all, add AI, so that AI is essentially managing the entire industrial process. Taiwan has been making the machines that go into factories around the world for decades. The United States has a good deal of AI. You are developing a good deal of AI. So if the United States and Taiwan get together, our AI, your machines, let's go build the industrial internet together. A second area is biomedical. Taiwan has a single-payer medical system for decades, and you're sitting on a mountain of medical data that has to be harnessed to develop devices. And if you can find a way to harness that data, you can develop incredible biomedical devices which particularly address the issues of aging, because around the world, all developed countries are having demographic problems, and if you can learn to address those issues, there's tremendous progress that can be made. The third area is with respect to circular economy. Taiwan is a resource-constrained island. Necessity is the mother of invention. All around the world, people are going to be figuring out how do we deal with sustainable smart cities? How do we balance growing populations, growing urbanization, and at the same time, do it in a way where we don't destroy ourselves with the environment? Taiwan, there's really only one other country in the world that is trying to take a lead on this, and it's the Netherlands. So that means Taiwan is already in the top 2 potential countries in the world for developing circular economy. And bringing AI and sustainable technology through the development of smart cities is definitely an area where Taiwan would have an edge. And the final area is with respect to augmented reality and virtual reality and bringing AI into augmented reality and virtual reality. So the HTC Vive, many say, is by far the best virtual reality platform that exists. Google has come to Taiwan and has decided to make Taiwan its hub for its software, hardware integration for all of East Asia. Down in Kaohsiung, you have a fun tech hub which is emerging, which is bringing AI and VR together. So we're talking about training the AI. Bring the AI into the VR and train it to do the right things. So there are plenty of areas that Taiwan has a definite comparative advantage, and we would like you to view the United States as your partner as you engage in this. So when you are fighting in the dark against the bigger enemy, or bigger, I shouldn't say that politically, stop the camera. Too late. Too late. Against the bigger opponent, right? Remember that the United States is there fighting with you. Thank you.
Okay, I think it's pretty much for today. And let's thanks again for our speakers and officers from the IIT Executive.